Hello there. Today we'll be doing interweaving strings. In this particular problem, we are trying to see if we can form the string S3 with S1 and S2. The way we will be doing it will be choosing one character over the other character and making a decision. So basically what that means is, suppose we have A, B, C, and D, B, C, and we need to form A, D, B, C, C. So if we can choose a character, then we choose one, and now our pointer, is there a way to point up? Maybe not, but let's just do an A to do it as an arrow, pointing up arrow. So we move this item forward every time we get an item. Okay, so then we look at the A item. If it's okay, we add another item to it and we shift. And we shift this item. Of course, this particular item here is still at 0 index. At a D, we get the index D, so we have D here, and we move the index to B. And we have B, we have to move this index as well. So we just keep moving it forward and building up our string. Of course, we could, as you can see here, there's a B here or a B here, and we could take any of the following. So let's just take this one, and now we have a C. Of course, now we'd have to take a B, and then take a C, take an A. Of course, now this is out of bounds, and we take one more C, and we are done. So to complete this problem, we must make sure that if length of S1 plus length of S2 does not equal length of S3, then it will be false because we cannot add up to this particular, we can't interweave these two strings to form S3. Another thing to note is that, oh, I forgot to keep moving this A here. Of course, we move it all the way to the end, right? So another thing to note is that if we are able to move all the way to the end of the string, then we are good to go, right? So that is our first base case. So if I equals length of S1 and J equals length of S2, we can return true. We also know that there can be a decision tree when we see two B's and we have to decide between the two. So it is wise to have a to see if this is in the DP already and return the DP of that I and J at that location. So this is a 2D dynamic programming problem. So we need to put that here, and we need to set up our DP. We're equal to a empty item where key is equal to the I and J location, and the value is equal to the Boolean. So with that, what we did earlier was if I is less than length of S1 and S1 at I is equal to S3 at I plus J, then we're going to try to look forward to see what happens if we move one forward. And if we reach the end, we can return true. If we do not reach the end and we get a false, we'll skip these two, and eventually we'll return false and send back a false answer. So now we have DP of I and J equals false. Return false, because none of these things are equal, and nor even if they're equal, the next item is not. So with that, let's run the DFS of 0, 0, starting at the 0th index for both items, and get to the end. Let's run the code. Oh, runtime error. Let's see. This is not indexed. Oh, indented. So it is returning true. So we have a pretty good, efficient answer here, and it fits the description of how the problem works. It's just kind of like reading out the problem eventually, once you get very used to this type of problem. Of course, I did not see it, and I think I need to see this many more times to see this very straightforward solution. And now let's convert this to a bottom-up approach, where we are looking at the last item in the index and getting it to the first item. So how does this work? Yes. So in this particular problem, we're going to do bottom up. That means we're going to start from the reverse end of things, and we need to create a DP of that particular grid. So we're going to create a false times the amount. Oh, whoops. So we need we get a false array times the columns of S2 plus 1, and for I in range of length S1 and plus 1. So this will give us a grid like this. So AA, where's S1? S1 is the columns, and S2 is the S1 is the rows, and S2 is the column. So let's get the columns. So the columns is D, B, B, C, A, and of course we need to set the true case, which is here. So dp of -1, -1 is going to be equal to true. Once we've set that, we're going to reverse from this particular location to see if we have matching items. So we should have, we're going to try to match each column to our string first. So let's see our string: AA, D, BB, C, BC, AC. Okay, so we check the first item back here. So we have a C, and we have an A here. So everything's going to be false, like as we have a pointer pointing to the item again. So is the item in front of it false? Well, yes. So false, 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 and false, because we're only getting the the columns here, this particular column, and this does not match any of these, and does not match forward in place. So that's why we're returning false. So for this one, as we can see, there's an A for the first item, and we are returning true because we matched. And look below, it is a matching item. So with that, we can keep moving on and look at A. A is matching, so that's also true. Then we look at C. C, is C matching? Yes, it is matching, so we have true here. Then we move to B. Well, B is matching, so we have here. And is B matching to this C? Well, no. As C matching, yes, C is matching, but it is pointing to a false. That means we have used the C already. So this is going to be false, and this is going to be false. Let's run through the whole thing. I think will be helpful. So let's see. We're going to point now. We're pointing to 2 before. So this is going to be pointing to an A. So is this an A? Nope, false. So is this an A? Well, we're moving already. We're moving 1 before. So because we have, so looking at a C now. Well, a C, that is true. So we have a true here. So then we move to the B. This is false. Then we move to the C. Do we need a C here? Well, we can say it's true because we do need a C here. We can pull a C in. And let's go to a B. Well, we have looking at a B, so we're going to turn true. And we're looking at a D or a C. We don't have a D or a C, and we're looking for a B, so false. As you can see here, we're building up to an answer. Once we get to the end, I think it'll be much more clear about what's going on here. But let's just keep going. So now we're running, it's basically DFS, but we're doing bottom up. So basically, if you understood the DFS method, I think it will be very clear what's going on. So now let's look at the C item, because we're doing the I plus J. We're 2 before now, and we're looking for a B or empty. And so that was empty, so return false. So now we're looking for a B, that's a true. And now we're looking for a C. C is true. And we're looking for a B. And B, they're both true, because the one in front is true. So we can pull those items. Now we're looking for D, and D is true. So we used up all of these items. And now we just have these 2 A's left. Of course, we have to start at the beginning again, looking at the B. So everything here is false until this last item here. The reason is that as we move to the B and the C here, the A is false. B here, oops, B here, the C is false. And everything pointing forward to it is false because we've used it up. We're now just pulling from the column now. So that's an A, so return true. Same thing here. We're going to be pulling everything from here, but since the start is false, even though this is returning true, we have used all of these up already, and now we're just pulling the A. And now we can return true at DP00. So in this way, we are evaluating the truth value of the item ahead in terms of column and in terms of row, and using up each character to determine if we can get to our particular answer. Hopefully this makes it more clear about what we're trying to do. Okay, so here we go. For I in range, length of S1, go by -1, -1. For J in range, length of S2, these are the columns. -1, -1. All right. If I is less than length of S1 and S1 is basically I equals S3 of I plus J, and dp of I plus 1, the one in front, is true, then dp of ij is true. If j is less than length of S2 and S2 at j is equal to S3 at I plus j, and dp of I and j plus 1, dp I and j equals true, return dp 0, 0. Yes, so we're returning true. And let's print out that dp so we can verify that's exactly that our dp is correct. As you can see here, we do need to print out a new line every time to make sure that this makes this more legible for us. Oh, okay. Is that how you print a new line? Let me just. Yeah, I'm pretty sure that's how you print a new line, but it's not working. Well, doesn't matter. Okay. I think that the reason is because, well, okay. Okay, this is gonna be in reverse, and that is not what we want. So, for I in range, length of dp, okay, great. And so this is exactly what we're looking for. See, false, false, true, false, true. As you can see, it matches these lines here, and these are all true, and the false and false true. So that's one way to verify that the logic was as expected. And this is another solution, the bottom-up solution for this particular problem. So what we've learned today is that we are making a decision to whether to use one or the other, and upon that decision, we will decide, we want to know what other possibilities, and that's why from that particular location, that's why we have the DFS call. And we were able to convert this into a bottom-up approach because we had the two variables, I and j, and we had the logic of how to traverse through our DFS call and look at the items that we have built up. Both of these solutions is a O of n times n space-time complexity, because we are using the space by using a DFS call and as a bottom-up approach, and we do have to go through every single item. The thing is, we can also, let's see, interweave. We can also just use a single row, reduce the number of rows that we need, but it will be less easy to find, see, but we just have to create a new row and whatnot. I think that should be all for this particular video. I hope you learned something today, and that thing is that our way of seeing a 2D dynamic programming problem, and where decisions need to be made, and when it is ready to return true, and to convert that into a bottom-up approach. Well, thank you very much for watching. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.